Welcome, builders. So today we're going to be talking about dependency injection. And I know that's kind of a buzzword in the industry lately. It's really a popular design pattern, and that's for a reason. It's very powerful. But I know it can also be kind of daunting because what the heck is dependency injection? So first off, if you haven't watched our course on interfaces, I highly recommend you do that first. So if you haven't, pause this video, go back, watch the course on interfaces, and that'll kind of give you the underlying foundation that you need to understand dependency injection. So if you have that, we're ready to get started. We're going to start off by going over the board, and we're going to go over the concept of dependency injection. And you may also hear inversion of control, so we're going to talk about that. We're going to look at some examples of dependency injection and how it works. Then we're going to hop over to Visual Studio and look at some actual code examples, both in .NET Core and .NET Framework. Okay, so let's get started. Okay, so we're on the board, and to start off, what is dependency injection? Well, dependency injection essentially just means that instead of an object creating sub-objects that it relies on or depends on, those objects are injected into that object. So one of the best examples I've ever heard of this is, let's say we're designing a laptop, and our laptop, let's say the first run of it needs to run on a Intel solid state drive. So we wouldn't want to hard code our laptop to only use Intel solid state drives. We would want it to work with several drives, right? So let's say Toshiba comes along and it makes one that is twice the speed and twice as fast. Well, we want to be able to swap that out, take out our old Intel solid state drive, put it in the new Toshiba, and we're good to go. Programming with dependency injection is much the same way. So if I have maybe a logging service where I need to log error messages that happen within my application, well, if I take in an interface to that service, I'm not pointing directly to the concrete logging service. Instead, the service is injected and I can talk to it through the interface. Okay, so let's take a look on the board and show you an example. So let's say we have our laptop, and to simplify things, it's going to have one component, and that's the solid state drive. So we'll have this over here. Okay? As we said, if we hard code our laptop with one drive, we're limiting ourselves in that if something changes, we don't want our laptop to be so intertwined in this one drive. We want it to talk to a generic interface so that it can be swapped out as needed. Okay, so when instantiating this laptop, for instance, we wouldn't want the laptop itself to instantiate the solid state drive. We want this solid state drive to exist separately in its own object that may have other dependencies injected into it, like maybe it's certain components of that solid state drive are then injected into that. But for simplicity, we'll keep it here to where this solid state drive is a separate object outside of our laptop. Okay? The laptop in its constructor then takes in some sort of interface. So let's make a copy of this, and we'll change this one to solid lines and the laptop to use a solid line, since those are concrete objects. And this is going to be an interface, so we'll do a dashed line. And let's say this is ISSD. Okay, and that the I signifies that it's an interface. So this laptop has an interface to the solid state drive that it will be using, and it will talk through this interface. So let's say this interface Let's build this out real quick. This is going to have, let's say, two methods. This will have the ability to read, which we would say maybe it gives us like a byte array back if we do a read. And then there'll be a write, where you can write a byte array. Right? So essentially, this hard drive or solid state drive has two methods, read and write. And that will be what our laptop uses to communicate with that drive. And to illustrate this, let's say this is the Intel solid state drive. And this is maybe the first run of this laptop. We're going to launch with this Intel solid state drive. So this Intel solid state drive is going to be injected into the laptop such that the laptop doesn't even have to know about the implementation. It's strictly talking to the interface, this iSSD. So my laptop can live independently of that Intel SSD. Both of them can then change, grow, be modified as needed without being dependent on one another. So they're truly decoupled in this sense. Okay? And now, since the laptop is only talking to the interface, now we could have maybe a new solid state drive come around, like we said. So let's say this one is a Toshiba SSD. Now this one could be injected into our laptop and it would work just the same because our laptop is only communicating through that interface. So another term you may have heard of is inversion of control. And a lot of times inversion of control and dependency injection are kind of used interchangeably, but technically inversion of control is the design pattern, and then dependency injection is the actual implementation of that design. So that's the overarching idea of dependency injection and how it works. And you get kind of the concept behind it and the power of it. Now our application can be built strictly on these interfaces, and we're not actually dependent on managing these services within the application. They can be in a separate class library. They could be, they could still be in the same project, but especially in a multi-developer environment, it's helpful because you could say, okay, well, developer A, you're going to go build out the Toshiba SSD, and I'm going to go build out the Intel SSD, and then developer X is going to go actually implement the laptop. So you could have three developers independently working on each component, and then they would all communicate together using dependency injection and the interface. So now we're going to hop over to Visual Studio and look at an actual project that uses dependency injection. It's actually two projects. Most recently, ASP.NET Core has its own dependency injection built into it. So we'll see an example of that. And then we're going to look at a .NET Framework, an older project that uses dependency injection as well. And for that, we use a NuGet package called AutoFac. So first things first, hop over to github.com/buildsharper. You're going to go to repositories and clone course 402. So download that, get it cloned and running on your local. Now we'll hop over to Visual Studio and take a look. All right, so we're in Visual Studio and I've got course 402, the solution pulled up, and you can see there's two projects within this solution. There's the Web Core project, and then there's the Web Framework project. And as I said, the Web Core is the ASP.NET Core version, and that both of these are MVC projects. The Web Framework is the .NET Framework version, a little bit older project. And we're going to show how dependency injection works with both of these. So first off, let's look at the Web Core project. As I said, ASP.NET Core applications have dependency injection built in. So we're going to leverage that. You can still use your own dependency injection provider, but you don't have to. You can use the one that comes out of the box. So in this case, let's take a look. We have, first of all, let's Let's run the application and see what it does. All right, and we can see this is basically just an out-of-the-box web application. This is a .NET Core MVC project, and it just loads up the welcome screen. But on the back end, let's take a look at the database and see what happened. So I'm in SQL Management Studio, and in my Build Sharper database, I now have this log table where it can store a message, a detail, and the date created. So I'm going to query this table. You can see the last time I queried it, I got 0 results. So now that my site has launched, let's take a look. And now you can see we have a row. User visited homepage, and then .NET Core is in parentheses, and this just happened. So back in Visual Studio, let's take a look. So as I said, this is just a out-of-the-box MVC project, and as you can see, it was loading up the default homepage. Whenever that homepage loads, we're logging it to the database. So if I go into my home controller, I can see, first off, I have a constructor here for my home controller, and this iLog service interface is being passed into the constructor, and then I have my own local copy of log service. This right here is dependency injection. So basically, when I have my home controller object, I'm specifying what needs to be injected in order for this class to operate. And in this case, it needs an instance of an iLog service. So I don't have to know the implementation of the log service. This could be something that's going to log to a text file, or send an email, or drop it in the database. My home controller object doesn't care and doesn't have to worry about it, because that service is being injected, and it can just talk to the interface without having to worry about the details. So, and here's an example. So on the home page, this index page, we're simply doing a log service.log, and we're logging that same message we saw in the database, this user visited homepage, .NET Core. Okay? And then we just do a view to show that homepage. And now if we want to go take a look at our service, we can see how this works. This iLog service, this is our interface. So this is all that home controller needs to talk to this service. And it's a void log, takes in a message, and then an optional exception. So we could use this service, for example, if say we have our code in a try catch and we catch an exception, we could use this service to log that exception as well. And then the implementation of this service is the dblog service. So with this implementation, it's actually going to log it in the database, as we saw over in SQL Server Management Studio. Right? So this is going to open up a new log DB context. This is using Entity Framework. We're adding a new log message and then saving our changes. And by the way, if you aren't familiar with this, we do have other courses on Entity Framework and MVC. So if all of this is new to you, hop over to that course and it'll help you have more context for this course. And then the last piece of this is the log object. So if I go into my models, I can see we have log.cs, where it specifies same columns that we have in the database, our properties here. So message, detail, and date created. And then we have our DB context, which allows that object to talk to the database. Okay? And we have our connection string in our app settings JSON. Okay? So now we've seen the home controller, we've seen the iLog service, we've seen the dblog service, and we've seen how things get injected into all of that. But how? How does the dependency injection actually make things happen? Well, all of that happens right here in program.cs. We can see we're using this builder object where we're basically creating a container that our application is going to live in. And it's in memory, and it's basically loading up all of the resources it's going to need to run the application. So in building this container, we're specifying, hey, for this interface, here's the implementation I want you to use. So for the iLog service interface, here's the DB log service that you should use. That happens right here on line 8. Now, anything that injects this log service will receive the DB log service. And that's it. So as I said, with .NET Core, it does a lot of stuff for you. And it can handle dependency injection out of the box. So it's a very powerful tool, and it allows you, like we said, to build your applications in a decoupled manner. So I can independently work on my log service, I can independently work on my web application, and then I can bring the two together with dependency injection. And if that log service ever needs to change, it's easy to swap out without actually having to touch any of the code for my web app. Okay? So now that we've seen that, let's hop over to the .NET Framework version. So I'm going to set that as my startup project, and we'll run it. Okay, so we've got our .NET Framework app pulled up, and we can see this is the older template. Looks a little bit different than the last example, but this is still an out-of-the-box MVC project. It's just using .NET Framework instead of .NET Core. Okay, so let's see what happened. It loaded up the web page, but now we're going to go back to SQL Management Studio and take a look. So here's our old results. Let's go ahead and run this again. Now I can see I've got 2 entries, and that second one is labeled the same but with .NET Framework. Okay, so let's take a look at it in Visual Studio. Okay, off the bat we can see there's a lot of similarities. So I'm in my home controller, and this constructor looks pretty much exactly the same. It's taking in an iLog service, and it's setting it to a local log service, which it can call throughout the home controller. Okay, and here on our home page, the index, we're doing a log service.log, user visited home page, and then .NET Framework is in the parentheses. And very similarly as well, if we go to the implementation of our DB log service, it's using Entity Framework as well. Here we're doing our log DB context, adding a new log entry, and then saving the changes. So far, it's all pretty similar. But you can see we don't have a program CS. Back in .NET Core, we had this program CS where we were able to add our service to the builder. So in our .NET Framework project, we have this configuration.cs. So let's take a look at it. So here we're doing a container builder, and this comes with AutoFac. So to get AutoFac, we're going to go to NuGet Package Manager and do a search for AutoFac, AutoFAC, and that will pull up the dependencies that we can pull in. In this case, we're going to need autofac.mvc, autofac.webapi2, as well as AutoFac itself. So back into our configuration CS. This is really cool, and this is why I like AutoFac. Even with all the built-in things with .NET Core, this is a really cool feature of AutoFac. So here in configuration CS, we have our container builder, and we're doing a register assembly types. This is where all the magic happens. This is where it's going to load in all of those services within our application and put them in this container that can then be referenced for all of these dependency injections that are happening throughout our application, where those objects are simply asking for the interface. They're saying, I need an instance of this interface in order to be instantiated. Okay, so our home controller, for example, for that to be instantiated, it needs a concrete implementation of the iLog service. And in this case, it's going to be the DB log service. But we take it one step further here with AutoFac, because you can see I'm specifying a where clause of what will be loaded in. And it's where the name ends with service. So anything in my application that ends with service will be injected into the container. And that's really cool because I don't have to go edit this file over and over and over with each new service. it's automatically going to build it into that container. So whether I have one service here or 100 services, it's all going to work right here within our configuration CS. And we can see it's doing it where it's loading everything that ends in service. It's loading it in as an interface. The properties are automatically wired up, and it does allow for circular references just in case that happens. And then we're loading up a single instance, meaning that if we have a DB log service, it's not going to create multiple instances of that service. There'll only be one. So this also ensures that your application is being efficient in using and allocating memory to these services. And that's it. Hopefully you guys now have a better understanding of dependency injection and how it works. And I hope you understand the power of dependency injection. As we learned back when we were talking about interfaces, our applications become decoupled when we no longer have to create those instances ourselves. Instead, we talk with the interface, and that interface can then be implemented in a separate service, a separate class in our application. And with dependency injection, we can now have our objects simply say, to be constructed, I need implementations of these interfaces, right? So our example on the board was a laptop. So I want to build a laptop that can talk to any solid state drive. So that laptop isn't going to be hard-coded with, let's say, an Intel or a Toshiba. Instead, it's only going to talk to the interface, and now those implementations can be swapped out as needed. Then we took a look at Visual Studio with a .NET Core application and .NET Framework, where both of them essentially do the same thing, but one uses the built-in dependency injection with .NET Core, and one pulls in a third-party library called AutoFac, but they both accomplish the same thing. So up next, it's time for everybody's favorite segment, homework. So as always, the first part of your assignment is to go download the repo. Go to github.com/buildsharper and download course 402. Clone it on your local and get it working. Then for part 2 of your assignment, we're going to go back and leverage a piece of code that we had in the interfaces course, and that was for a messaging service. So I want to update the website to have where the user can input a message and click send. That will then go into an iMessage service that gets injected into the home controller, and it will send the message. And now the home controller doesn't have to know the details of how that message is sent. That will be done in your concrete message service implementation. So there you can decide whether that message goes to a text file or a database, or maybe it sends an email. That's up to you. Once you've got all that working, push it up to Git, create a repo, get it pushed up, and then share it with us on Twitter. Reach out to us at BuildSharper. We'll be sure to give you props and a retweet. Or if you're having trouble, you can reach out to us on Twitter as well. That's going to do it for now. We'll see you next time.